Okay, welcome to a new video. And in this one, we're going to be looking at the key features of a quadratic function. Very specifically, we're going to be looking at the parent function, just basic x squared. So we have g of x equals x squared here. You can see it gives us this nice parabolic shape, which kind of looks like a U. We have our vertex here at 0, 0. Our line of symmetry is the y-axis. And then also we have, you can see our coordinates here. So -1 squared gives us 1 squared gives us 1. 2 squared gives us 4, -2 squared gives us 4. Our next one would be 3 and 9, and -3 and 9. So when we talk about the key features, we're typically talking about the domain and range. So what possible values are there anyway? And then also things such as kind of the shape, which here is the parabola. I talked about the line of symmetry going through the vertex. That is definitely a key feature of a quadratic. But then also we're going to be looking at where the intercepts, so where is the basic y-intercept and x-intercept when it hasn't been transformed, and then what are those intervals of increasing and decreasing. So let's start with that domain. A reminder here that when we're talking about domain, we're talking about every possible value that we can plug in for x, and we'll actually get a y value out. So looking at the graph, we're really saying how far to the left is my graph going to go? And I know that this graph extends, even though my picture here doesn't have my arrows because it was a screenshot. But we know that it's going to keep extending all the way to the left, and then also it's going to keep extending all the way to the right. So the domain would be from negative infinity to positive infinity. The other way of thinking about that, though, is what type of numbers can we raise to an exponent? Well, any number can be raised to an exponent, and so we can plug in any number. After we do the domain, then we can do the range, because the range is dependent on the domain. So now I can look at range. Well, if x is saying, or sorry, domain is saying what x values can I plug in to get a y value, well, the range is saying what then are those y values? Looking at the graph, I'm trying to figure out how far down is my graph going to go. And I noticed that for a quadratic, it actually stops. When it hits 0, it turns around. And so the furthest down it's ever going to go is 0. And this point is a point on my graph. It is a point. So it is going to get this hard bracket, which means 0 is included. Pretty much that is saying if I did 0 squared, I would end up with 0. So that point does actually exist. Then we're trying to say, well, how far up is my graph going to go? These arrows tell me it continues forever, so I can say that it goes up to infinity. Another way of thinking about this for an x squared specifically is saying when we square numbers, what type of numbers do we get out? Well, we know that any number squared is going to give us a positive number, and that is why we only see positive numbers here, including 0, because once again, if I square 0, I end up with 0. And so this is our domain and our range. So we can plug in any number and we'll only get positive numbers out. Okay. Now that we've looked at domain and range, let's go ahead and look at the next one, which is intercepts. So we like to see where does our graph cross either our y or x axis. In this case, it's right here. The x-axis and the y-axis both have an intercept, and the intercept is 0 for each of them. So I would say my x-intercept is equal to my y-intercept, which is equal to the coordinate 0, 0. So just a basic one, if I plug in 0, I get out 0. And we can talk about that here when we're looking at our range as well. Lastly, let's quickly talk about intervals of increasing and decreasing. When we're talking about intervals of increasing and decreasing, we're very specifically saying for which x values is my graph going up, and for which x values is my graph going down. Now, some people look at a quadratic and go, oh, it's always going up. But when we're talking about this, we're actually saying as I move from left to right. So I like to think about my function as a roller coaster. And if I'm on my roller coaster and I'm moving through it, am I going downhill or am I going uphill? And so if we look at that, I'm going to do red for decreasing and green for increasing. That means my decreasing interval starts when, because we know that this goes on, we know that it's not going to turn around anywhere because it has this nice U shape. So whenever I get on my function as high up as I can, so all the way, and remember we're talking, we're really talking about x values here. So as furthest to the left that I can hop on, my graph is going down. So my decreasing interval is going to start at negative infinity. So once again, that's x equals negative infinity is where we're starting. And then we say, well, where's the point where we stop? Well, we stop here at the very bottom of the hill. So we're stopping at x equals 0. I'm going to use soft brackets for both of these. And if you aren't positive about the hard brackets and soft brackets, you can go watch one of the other videos on interval notation. Infinity always has a soft bracket because we can't reach it. Up here, I put a hard bracket on the 0 for the range because that was included in my range. 0 is a y value I can get out. When it comes to asking about it here, we're really asking, is the 0 in the increasing interval or the decreasing interval? Well, it's really in neither, because at the very bottom of my hill, I'm no longer going down, nor have I started going up. So that is why it also gets a soft bracket, is that I'm decreasing all the way up until I get to 0. So if I want to be very specific, I could actually change this to I'm decreasing from x equals infinity all the way until we get to 0, where x is less than 0. On the other hand, we have our increasing interval. The increasing interval is where do I start going up? Well, if at 0 is where I stopped going down, it is also where I start going up. So we're starting at that x equals 0 point, and then it's just going to keep going up forever. And once again, we're really talking about to the right. We know that it's never going to turn around. So as far as I go to the right, my graph's going to keep going up. So it's going to go all the way to that infinity. Once again, I'm using soft brackets because I can't actually reach infinity. It's always a soft bracket. And once again, 0 was kind of that boundary. It didn't belong to decreasing, nor did it belong to increasing, so it got the soft brackets. And there you have it, our key features of a basic quadratic.